Okay, find the value of x for which P is parallel to Q. They say that the measure of angle 1 is 9x. Let's fill that in there. And measure of angle 3 is 117. Okay, well, the fact is if those lines are parallel, then we're going to have these two angles being congruent because they are corresponding angles. Okay, and if we find the value of x by setting 117 is equal to 9x, okay, then we divide both sides by 9. What we get is 13. If x was 13, 9 times 13 is 117. So that would make those angles be equal in measure, and therefore the line's parallel. So we know that x needs to be 13 in order for those angles to be congruent, and therefore the line's parallel. So that's how you do it. Okay, find the value of x for which L is parallel to M. This one's kind of interesting. You need to imagine this. Okay, imagine that there is a third parallel line running right through here. Okay, and I'm going to just put it right there. Okay, if that third parallel line was there, excuse me, and again, we're finding the value of x for which L is parallel to M. So let's say if that was true, that L was parallel to M, and we went one further and we said this other line that I just added is also parallel to all of them, then if this was 21 right here, this would also be 21 right here. Okay? And that would leave 21 remaining, since this whole angle right here, this whole angle is 42. If 21 of it was right here, because it is an alternate interior angle with this 21 degree angle and these two lines are parallel, then that would leave 21 degrees for this angle. And since these are alternate interior angles, x would also be equal to 21 degrees. Okay, so you need to do a little creative imagination here, and let me take all of these marks out and let's just talk about it one more time just to make it clear, because this is a little bit of a tricky problem in that you need to know what it is that you're supposed to do. So again, first thing that I did is I said they want us to find some value of x that will make these lines parallel. So we're saying, okay, if these two lines are parallel, and we threw this third line in here making it parallel as well, that's the big trick, because how else do you know what to do with this 42 degree angle? Okay, I don't know what else I can tell you to do except to say, imagine it like that, and then if we say, okay, if I've made that line so that this blue line is parallel to this line, then we know alternate interior angles are congruent. So if this one is 21 here, then this one is also 21 there. Okay, and because the whole thing is 42, that whole angle is 42 right there, that means that 21 degrees is up top, right here, and then there's another, out of 42, another 21 degrees left for right there. And because these two angles are, if this line is parallel to this, then these are alternate interior angles. If this one's 21, this one's 21 as well. That's what we get that from. Okay? You should definitely watch that several times until you get your mind around it, because it's a little bit tricky in that you need to know to create a third parallel line in there that runs right through that little vertex right here. And then that makes that a transversal line for two parallel lines, and that a transversal line for two parallel lines. Okay, one more slide. Find the value of x for which L is parallel to M. Well, if L is parallel to M, then that would make these alternate interior angles, okay? Interior, meaning in the interior of the two parallel lines, and on alternate sides of the transversal. And what do we know about alternate interior angles? They are congruent when the lines are parallel. So we can then say that makes 3x minus 42 equal to 87. And then we're going to take this side and add 42 to it. And we're going to take this side and add 42 to it. And then these two, of course, we did that because it's an inverse operation, so it undoes it. So we just get 3x left. And 87 plus 42 is 129. So when we do 3x divided by 3 equals 129 divided by 3, x equals 43. Okay, and if you plugged that value of x in here, it would calculate out to give you the exact same measure as this. And when these alternate interior angles have the exact same measure, we know the lines are parallel.